Hi, Ivy Bound 8th grade. So, with the circumstance that we're in, I am going to be posting video lecture slides. Now, I know that this first one is review, but I do want to be able to start with the review while we're getting the hang of everything and give you guys assignments based on something that you somewhat already know. And this also gives you a chance to be able to pause my videos and learn things that you might not have learned when I lectured in class. And if you were absent, then you are getting a chance to pretty much learn the lesson that you missed. So I am going to be clicking through the slides and giving my lecture as you follow along, and you can use these for your assignment. And I will be posting these in the following weeks and the following weeks, depending on what topics that we are doing, but you can expect lecture videos from me. Now, we learned about the electrons and energy levels. And if you look at this image in the front, that's the nucleus. And the first E1 is the energy level 1, E2, energy level 2, E3, E4, so on and so forth. Before we get into that, though, the periodic table is like a library. It is organized. Libraries are usually by genre, and it is alphabetized. And the same thing about the periodic table, the scientists didn't just take a bunch of the elements and plop them on a sheet of paper with no organization whatsoever. It is organized actually by the elements' properties. And the periodic table, as you can see here, is going to be organized in periods, going up and down in rows, and then in groups down the columns. So the periods or rows, the pattern that you can see is that the atomic number, aka the number of protons an element has, increases as you move across the period. So if you go from hydrogen, which is 1, to helium, which is 2, and then as you read it, as if you would read a book, going from left to right and then moving lines down, the atomic number actually increases. Now, in terms of the groups or the columns, you can see it's divided into group 1, group 2, group 3, group 4, group 5, so on and so forth. These groups have similar chemical properties, so those were divided into its similar chemical properties. So first, the periodic table's periods, the atomic or the number of protons, the atomic number increases as you move across. As you can see, 1, hydrogen, and then it moves down as if you were reading a book, like I said earlier, to 2, helium, and it increases, and then it goes 3, 4, lithium, beryllium, 5, 6, 7, 8, BCNO, and then as you just read across that, atomic number is going to be increasing, and that is equal to the number of protons that that element has. Now, these groups, you won't need to know all these, the lanthanide series and all of these colored in. I just wanted a visual representation so that you can see that groups are actually elements that are grouped up into the ones that they have similar chemical properties with. Now, the three classifications of elements, the three main ones that we are going to be learning are metals, metalloids, and nonmetals. However, I wrote 3 classifications of elements at the top in order of most to least. It goes the most or the majority are the metals, and then the nonmetals, and then lastly the metalloids. Metals, we know, are often shiny and they are great conductors of electricity and thermal energy. And these metalloids, which are the green section right here, as you can see, that is going to be the smallest section. The nonmetals are more than the metalloids, but the metalloids are often used in our electronic devices as conductors. Now, down to this yellow section right here, which is second most, are the nonmetals, and nonmetals are poor conductors. Most of the time, they're gases at room temperature, and they tend to be brittle when they are in solid form. Now, atoms, they bond together. Atoms, they combine in order to form these things called compounds. And these compounds, which are a combination of atoms, are held together by this thing called a chemical bond. And this chemical bond is a force, as you can see bolded. It is a force that holds these two atoms together. It is an attraction that holds these atoms together. As you can see here, the chemical bond in this diagram, say that this is H2O. This red thing right here is going to be the oxygen. And then if there's 2 hydrogens, it is this blue, the 2 hydrogen atoms. The bonds are going to be those little sticks. That little force right there is going to be that chemical bond that holds all of these atoms together. Now, before we move on, this is review that atoms contain protons, neutrons, and electrons. Now, neutrons are neutral and they don't have a charge. Protons are positive, and you remember that by the P. And electrons are negative. Now, the number of protons equals the number of electrons. I'm going to say that one more time. The number of protons equals the number of electrons. So if I said that hydrogen, the atomic number that we said is the number of protons equals 1, that means that it has 1 proton and it has 1 electron because the number of protons equals the number of electrons. Now, electrons have different energy levels where these electrons live pretty much. Different electrons in an atom have different amounts of energy. So the space where the electrons move around, those energy levels, as we saw on that first slide, the E1, E2, E3, E4, the electrons live on different levels. And the electrons that are closer to the nucleus, so E1, are going to be weaker in energy. And that's because the electrons need more energy to get to the electrons near the nucleus when they are bonding. And they need to use less energy to get to the ones on the outer layers, say E4 versus E1, because when they are taking place in bonding, less energy is needed to pull those ones than it is to pull the ones that are closer in. So with that being said, electrons that are further from the nucleus are then stronger in energy. It's important to know that the first energy level, E1, holds 2 electrons, and then it moves on to that second energy level. Once that first energy level is full of 2, it'll move on to that second, which holds 8 electrons. Now, this can be confusing at first, so I'm going to move on and break this up. So those first 2 bullet points stated that different electrons in an atom have different amounts of energy, and the space where these electrons move around are called these energy levels, as you can see in this image that was the first slide, where it's E1, E2, E3, and E4. So E1 right here is going to have more energy. The E1 is going to have less energy than the ones that are in E4. So E4 is going to have the stronger energy. And this just repeats what I just went over. It's the electrons that are closer to the nucleus that are going to be lower in energy, and the electrons that are further from the nucleus are going to be stronger in energy. Moving on, the next 2 bullet points we went over is that the first energy level holds 2 electrons and the second energy level holds 8 electrons, as you can see here. Once that first level fills up with 1, 2, it moves on to the next one and it fills up 8. And I did demonstrate in class how these are drawn when we went over the Lewis dot diagrams. It's just a nice little review. Now, if we go back to chemical bonding, a chemical bond is caused by the positive nucleus of one of the atoms being attracted to the negative electrons of another atom. We know that neutrons they have no charge, and protons are positive. So these positively charged protons in the nucleus are attracted to these negatively charged electrons, kind of like magnets, and that's kind of the driving force of these chemical bonds. Now, a valence electron is the outermost electron of an atom, and those are the ones that participate in chemical bonding. So these are all valence electrons. The ones on the outside here, 1, 2, 3, 4, 5, 6, 7, are going to be valence electrons, and they're all valence electrons because they are on that outermost energy level, and those are the ones that take part in chemical bonding. The number of valence electrons in each atom can help us determine the type and the number of bonds that it can form. So if hydrogen has 1 valence electron, then it can form 1 bond, and so on and so forth. And you can see an example of that right here. Carbon has 4 valence electrons, and that number of electrons in carbon helps us determine how many bonds it can form. Because there are 4 unpaired electrons, it can form 4 bonds. So the number of valence electrons, because they are the ones that are taking part in this bonding, it'll help you determine how many bonds can actually be formed. Now, we went over a worksheet of electron dot diagrams, but just to go over, electron dot diagrams shows and is a model that represents valence electrons in a specific atom with dots around the element's chemical symbol or that chemical abbreviation that we went over when we learned about the periodic table. Like so, this is what they look like. And it's important to note that these noble gases, group 18, remember that they are grouped together based on similar properties. They're called the noble gases, and that's because everybody wants to be like them. They have 8 valence electrons, they are stable, and all these other elements want to be like them. They want to fill up their unpaired electrons, their unpaired valence electrons, and be like this group 18 noble gas group. I added this photo in here because it's pretty cool because these are images of the gases when they are burning. This is what they look like. And lastly, an important thing to note is that stable atoms are atoms that are paired. Stable atoms are happy. They have a pair and they are stable because they are not alone. Now, atoms that are unpaired, that have unpaired dots like hydrogen up here, right here, this unpaired dot makes them unstable. This is basically what I wanted to go over in terms of electrons and energy levels. If you do have any questions, I have posted on my schedule what the office hours are for 8th grade. I do have office hours on Thursday. I think it's at 8 a.m. to 9 a.m. So I will be on GChat and I will be actively checking my emails during this time if you are confused about how to complete assignments, what's actually going to be graded, if you have any questions about this lecture. So make sure that you contact me during those office hours. And if you can't make it during that time, just send me an email and I will respond within 24 hours to any questions that you have.